Can gain bandwidth limit your op-amp circuit? Have you ever wondered how the gain bandwidth product affects your operational amplifier circuit? This is a key concept in electronics that can really shape your designs. Let's break it down together. The gain bandwidth product is a constant for each operational amplifier. It is calculated by multiplying the amplifier's gain by the bandwidth at which that gain is maintained. For instance, if an operational amplifier has a gain bandwidth product of 1 million Hz and you set it to a gain of 10, the bandwidth will be about 100,000 Hz. This means that as you increase the gain, the bandwidth decreases. Now, let's look at open-loop gain and closed-loop gain. An operational amplifier has a very high open-loop gain when there is no feedback. However, this gain drops as the frequency increases. When you apply negative feedback to set a specific gain, the bandwidth is limited by the gain bandwidth product. The closed-loop gain multiplied by the closed-loop bandwidth will roughly equal the gain bandwidth product. What does this mean for your circuit design? If you need high gain at high frequencies, the gain bandwidth product can create a limit. For example, if you want to amplify a 30,000 Hz signal by a factor of 50, a low gain bandwidth product operational amplifier may not be able to do this effectively. The bandwidth at that gain would be too small, leading to distortion or reduced output amplitude. Additionally, there are other limitations to consider, such as the slew rate. The slew rate defines how quickly the output voltage can change. Even if the gain bandwidth product suggests that the bandwidth is sufficient, the slew rate can still restrict the maximum frequency and amplitude of signals without distortion. When designing circuits in analog electronics and embedded systems, it is essential to choose operational amplifiers with appropriate gain bandwidth product values based on your required gain and signal frequency. Keep in mind that the layout of the printed circuit board and parasitic effects can also impact the effective bandwidth and gain. This means that the actual performance may be less than what you calculate theoretically. Understanding the gain bandwidth product is vital for designing operational amplifier circuits. It helps ensure that your circuit meets the desired frequency and gain requirements without distortion or loss of signal integrity. So, when you're working on your next project, remember how gain bandwidth can limit your operational amplifier circuit.